All right, this is How to Survive Calculus by me. And yeah, math is rad. Rock on. So the first thing you need to know going into calculus is that it takes a lot of time management because it's like a really hard class. And that studies show like that studying incrementally is better than studying all at once, and that really helped me. Like every day I'd have an hour time frame where I just sort of reviewed calculus, and then I'd be ready by the time the test came around instead of having to like cram study. And then just like anything else you want to be good at, if you want to get a good grade in calculus, you have to practice it a lot. Then right here we have my good friend Drake getting swole on his calculus grind, shoulder pressing the integrals and derivatives. A major key to success in calculus is Mr. Richard. He's a math wizard, so you should try to get as much help from him as possible. He's like available before school every day, so if you won't like ever need help with something going in before school, is like a really good option. And then asking a lot of questions is also super important because like a lot of the concepts you're going to learn are going to be really challenging and seem sort of like impossible sometimes. So you should pester Mr. Richard with as many questions as possible to learn as much as possible. And then right here, I just have a picture of you guys chucking questions at Mr. Richard. And yeah, dope. Top tier resources, Khan Academy. It's pretty self-explanatory. I'm pretty sure you guys have used it before. Just Google any math topic plus Khan Academy, and they'll have like a really good walkthrough video with example problems. It's really useful when you're like in the intro part of a unit and you want to sort of get ahead of the curve for being in class. If you just watch a quick video on it, you can go in the class the next day and like be ahead of everyone, and it helps a lot with your pacing of work. Wildmath.org is super cool too. I only found out about this like halfway through the school year, but I wish I'd known about it the whole time because there's like practice tests on it. And you can basically go in and for whatever chapter you have, you can go and take that chapter's like practice test. And it'll be super like similar to what you're actually going to take in class on test day. And it gives you like a really good idea of where you're at as far as being ready for the test, which lets you sort of decide your own fate on your test results because you can basically figure out what you're going to get before you actually take the in-class test. And then the best resource of all is your classmates. Getting a one-on-one conversation about anything is the best thing you can do to help yourself and help the other person. And that's something I wish I'd done more at the start of the school year as well. Because like the first few units, I didn't really, if I had a question, I'd only ask Mr. Richard. And Mr. Richard is really helpful, but he has 26 like students in a class to go to. So if you can just get a conversation with someone else who's good at this current unit, it's useful. Winning mentality. So this is sort of like the mindset you have to have because trying is everything in calculus. Like a lot of times you're going to be trying out these really hard math problems that are sort of intimidating. Like when you get into like integrals and derivatives for the first time with like big rules like the chain rule, like you'll probably want to slam your head against the desk just because it's sort of like weird to wrap your mind around at first. But if you just keep trying, it all comes pretty easy. The big thing is just not to give up because a lot of people would get distracted or they'd see like a really hard problem and be like, dang, no way I can do this. And they'll go on their phones. And that's like the worst thing you can do in calculus because like if you go on your phone for one class period, you're going to miss so much. Like if you just even go on it for 10 minutes because the class moves so fast that you always have to be focused and like working hard. Derivatives. So this is sort of an intro to derivatives because this is sort of like one of the fundamental ideas you're going to study all year in calculus. So a derivative is basically a fancy term for slope or rate of change. So learning about derivatives is simplified a lot if you understand how physics applies to math, because in physics, you know that a position function, the slope of a position function gives you the velocity and the slope of a velocity function gives you acceleration. And that's sort of the same fundamental idea that you'll learn about with derivatives. And yeah, so here's an example problem for derivatives. So the question is find the derivative of x squared minus 2x plus 10 at x equals 2. So this problem is basically just asking you to find the slope of the function at x equals 2. There's a lot of ways you can do this. You can first do this by deriving the equation using derivative rules and then plugging in x equals 2 to find what the slope of that function is at x equals 2. You could also do this by deriving the equation or finding a tangent line to the function at x equals 2. So basically tangent lines, if you don't remember what a tangent line is from geometry, it's just a line that hits a curve or shape at one point only. So if you set up a tangent line at this point, it'll have the same slope as the function at this point. So you can then find the slope of the tangent line, and it'll be the same as the function at that point. So that's sort of useful. And yeah, if you want to derive this function in particular, you'd have to know the power rule. So the answer to this function is the slope of the function at x equals 2 is 2. Derivative of the function x squared minus 2x plus 10 is 2x minus 2. And then by plugging in x equals 2 into this function, you get 2. So once you derive this function, it's actually a pretty simple slope function as a whole. But yeah, you just need to understand the power rule to get how this answer comes out, which you'll learn about. Derivative hints part 2. So if you took pre-calculus, it wasn't a complete waste of time because you should be familiar with instantaneous rate of change. And a derivative is equivalent to instantaneous rate of change. Like the instantaneous rate of change equation is the same thing as a derivative. It's just the long way of doing it and extremely painful once you get good at the more efficient derivative rules, and if you don't remember the instantaneous rate of change formula, that is f of x plus h minus f of x over h, and that will find the slope at that point, or at any point from 0 of whatever your x value was. So yeah. So now the other big concept in calculus that you're going to learn about is integrals and area under the curve. And integrals is basically just a fancy way of saying area under the curve. The symbol for an integral is this little squiggly line looking thing, and as you can see, it is definitely resemblant of a squiggly line, but if you call it a squiggly line in class, you may be hit by an expo marker. I am first-hand witness to Mr. Richards' nasty fastball he can throw with his expo marker, and yeah, you do not want to be on the receiving end of that. So integrals part 2. You should all be familiar with Riemann sums from pre-calc. If you took it, obviously. If you didn't take pre-calc, it might be a new concept. So they basically just allow you to calculate a somewhat accurate representation of area under the curve by using either left endpoint or right endpoint rectangles. And they'll basically give you like an approximation of what the area under the curve is, but it isn't precise because you will always either be like slightly over using rectangles on a curve or slightly under, but you can get like more and more precise the more rectangles you use. And so an integral basically takes that concept one step further, and it uses an infinite amount of these rectangles over a set interval to calculate the exact area under the curve. And that's like super useful later on in the year. And there's 3 ways to go about solving an integral. You use the integral function in your calculator to find it. So that's basically the simplest way. You just plug in the function, plug in the domain, hit enter, and it'll spit out the answer. The other way is you calculate the area under the curve of the function if it is easy to do by hand. So basically, if it's like all linear functions or constant functions, it's really simple to just like draw out the triangles and rectangles and find the area by hand. But you probably won't see many of those on tests. And then the last way, which is the way that you'll learn first, is using antiderivatives to integrate your function and then use this new function to solve for the area under the curve. And that way by hand, once you master it, it really expands your sort of understanding of derivatives and rate of change and like integrals and all that stuff. And then I have a little math meme down here. It says remembers to add plus c on an integral, and then it was a definite integral. And I don't know. I guess you'll get the joke later on, but basically you don't need to add plus c when you have a definite integral. So here's an example problem for integrals. So find the integral of f of x when f of x equals 2x plus 2 from 2 to 6. I used the wrong form of 2 right there because I'm a great English student. You know me. You can manually find the area under the curve looking at the graph. You can plug it into your calculator or antiderive. And then, yeah. So down here I have another math meme as well. Level 1 crick, level 35 boss. It's basically, this is the instantaneous rate of change equation, and this is the derivative, and it's because they're the same thing. It's just like this is the more fancy and complex term. But yeah, so how do we solve this problem? The antiderivative of this function is x squared plus 2x plus c. And then you can do f of 6 minus f of 2 of this new function. Notice it's big F, not little f. To then find the area under the curve. And that will give you the final answer as 40. So when learning about integrals, a trick that really helped for me was visualizing the graph of the antiderivative of the function. This made it so I knew if I made a mistake when antideriving, which helped prevent me from making dumb mistakes on tests. So if you can sort of anticipate what this graph's going to look like if you know if your function that you're integrating is like a quadratic, then you know that the graph of the integrated function should be like a cubic. And then you can sort of like plot out in your mind, be like, okay, it should be like in this range of numbers, your final answer should be. And it's like a really quick way and good way to check your answer on tests. And it like just keeps you from making like dumb mistakes where you're like plugging a problem wrong in your calculator, because I've done plenty of that. Or you just do like some dumb mental math error. But yeah, it's just always nice to have like a quick way to make sure your work's in the ballpark. So in conclusion, calculus is a challenging class that offers tons of benefits as far as college readiness goes. College requires work and practice to become good at, and there aren't any true shortcuts other than working hard. And that's the big thing that I know Mr. Richard always appreciates, is if you go hard in class, you just stay focused, you show up, work a full hour and a half, and then just go out and enjoy the rest of your day. Because trust me, like those days where you just go in the class and sort of goof off in calculus, you can't afford it. Like if you miss like half a day even, you'll feel like really confused and lost because you just didn't get the instruction in class. So just stay mentally focused and challenged and you'll be fine. But yeah, as a whole, calculus is pretty fun. Mr. Richard is dope. And yeah, good luck.